It's Tekpub. Today, talking about behavior-driven design with Specflow. Have you ever tried TDD? Thought it was a pain in the butt? Couldn't really get your head into it? Writing all those tests kind of a pain? Well, you might want to check out behavior-driven development. There's a lot of tools out there, but Specflow is getting close to actually being easy and simple to use. In this demo, I will show you how to do a very simple application in 2 steps. First is going to be slow and methodical, talking about the concepts, and then I'm going to turn up the gas, and you can see how a BDD workflow is actually implemented. So let's take a look at BDD with Specflow. And before I get started, I want to mention that I'm going to break this demonstration into 2 parts. First part is going to be a little bit slower, and I will write out a scenario and kind of go along adding some code, filling out some steps, and the goal being just to show the flavor of the BDD workflow. And then I'll add in some more scenarios in the second part, and I'll speed things up a bit and start writing code in earnest. And also, before we get going, I do want to mention that everything you're about to see is subject to a lot of people's opinions, and BDD is full of opinions, right down to what you name things and what tool you use, whether you're doing it the right way. I will tell you that this is sort of a primer, and I'm kind of aiming it right in the middle of various opinions that are out there. I do encourage you to go read more if you're interested in the philosophy behind BDD, because again, it's all about getting your mind in the right spot. And that said, let's get to some code. So you can see I have a solution here with 2 projects, and they're both class libraries. You don't need any special project for working with BDD or Specflow. In here I've added 2 references, one to the NUnit framework. It's 2.5. I just downloaded it from NUnit. And the other one is to the Specflow DLL. I do not need any other special tooling. This is it. I installed NUnit, and then I added the reference to Specflow. And the other thing I want to point out is a conceptual shift from regular unit testing. I called this project Specs. I didn't call it tests. And that is the first conceptual shift when it comes to working with behavior-driven design. And these are literally executable specifications, or at least that's what they're supposed to be. And if you kind of think about that in a design sense, you usually write down the specifications of what you're going to build first. And then you go ahead and build what you're going to build based on those specifications. That, in a nutshell, is BDD. Testing, on the other hand, if you think about science, you might come up with a theory, then you might execute some tests against that theory. It's usually the other way around. Testing usually comes later. I think that's a mental block for a lot of people. All right. Having said that, what I'm going to be working on today is my super bowling scoring machine. And what it's just here to do is to be plugged into a bowling alley, and it's going to keep your score as you bowl. All right, so one of the features that our super bowling score machine is going to need to have is, of course, scoring. Other features might be entering users' names. It might even show the Super Bowl when a person is bowling their game. It might accept drinks, drink orders for the bar. For right now, the feature we're going to focus on is just simple scoring. So I'm going to add a new item, and when we installed Specflow, it dropped a few things into our project templates, and specifically it dropped some item templates in here. The one we're concerned with here is the Specflow feature. We're going to define a feature right now, and I am simply going to call this scoring. All right. So when you first put in the feature file here, it gives you a template. You kind of get your head in the game as to what you will be writing and using. This syntax, this stuff that you see here is a DSL, or domain-specific language, called Gherkin. And all these words are very specific. It looks for these things in order to understand what it is you're trying to do. And I'll talk more about that in just 2 seconds. But the first thing is a feature. What is it we're doing? The template here says we're doing addition. And then I love this meth. It's supposed to be math. Whoops, small scoring problem, or spelling problem there, huh? Okay, so in order to avoid silly mistakes, as a math idiot, I want to be told the sum of 2 numbers. Good. And then the scenario is in place to support the feature. And you take different scenarios to talk about how the feature will be implemented. This is all basic project management stuff, simple to understand. But what's actually happening here? And this is just plain English. I mean, what does this actually do? Well, every time you save this file, what you're doing is you're actually invoking a custom tool. And to take a look at what that custom tool is, we open up properties on this file, drag this thing over, and we're using the Specflow single file generator. So what this Specflow single file generator thing is doing is it's actually scanning this thing. It's parsing the values in here, and if we crack this thing open, you can see it's generated this file for us. And inside of here, lack of better words, is just a bunch of n-unit tests. These things are going to look for methods when they're executed. It's going to look for methods somewhere in order to run the tests. And it just basically uses reflection and so on. I'll talk more about that in a minute. But what I want to show you is that right off the bat, we can actually execute this. And to do this, I'm going to use the n-unit test runner. And I'm going to right-click here. If you've installed n-unit with Visual Studio integration, you should have a little entry in here that says test with. I'll say test with n-unit 2.5. And up it comes. Great. Here we are. So pulled in our assembly. It's taking a look for tests. And since we're using the n-unit framework underneath Specflow, Specflow is just a glorified code generator, if you will, here's our initial tests. Now, what happens if we run this? I mean, we haven't written any code. This is basically a template that generated some code for us. We run this, and, well, nothing really happens. We get green, but you should ignore that. It should be yellow. I'm not sure why it's coming across as green. I think it's a small bug. But inconclusive. Everything's inconclusive. Over here, you see question marks, and that's exactly as it should be. And what it's telling us here is, hey, there's no matching step definition found for this step. Oh, all right. Well, I don't know what that means. Well, let's come back over here and take a look at this. This is divided up into two sections, as I mentioned. The feature at the very top telling you what it is you're building. Then scenarios, adding two numbers. For instance, if we're doing a calculator, these guys underneath are called steps. These are the things that we're going to write code against. All right, so I could write code against these things to show you how this works. I'm not going to do that. What I'm going to do is take these things completely away and talk about scoring for bowling. So our feature right here is scoring. Pretty simple. And again, these features could come straight out of your team, as you guys have sat and decided, well, we should really show them an X instead of a number. We don't know the number yet because strikes are scored later based on later frames. So that's why we want to be specific up here, giving them on the first frame, ba-da-da-da. All right, so we are going to build this. There we go. The build succeeded. That's all good. The code got generated. I will mention that from time to time, when you're saving this, sometimes the code generator gets confused. You'll see various errors. The thing will pop up and say, don't know what this other thing is, blah, blah, blah. If you find that happens, right-click here and go to Run Custom Tool. This will execute the custom tool, this guy right here, single file generator, and it will take care of that problem. All right, well, now that we've done that, let's go back over to n-unit. And before we get going here, there's something I really want to point out, which is you want to go to Tools, and you want to go to Settings. And then up here, you want to go to Test Loader and Advanced, Assembly Reload. Make sure that Rerun Last Tests is checked, that all these are checked, in fact, because every time you build your project here, every time you build your solution, it will auto-run your tests, which is rad because it's a constant feedback. And so as you've got your specs going here, and you're building out your model, your application down below, anytime you make a code change and build it, you will have feedback as to if you broke something, which is always handy. Okay, so bowling a strike. What do we do now? That's a good question. Well, now that we have our features laid out, what do we do next? Well, as I mentioned, every scenario has steps in order to find out if that scenario is fulfilled. So what we need to do here is to add a step file, and that step file is simply some methods that will get called when each one of those steps is executed. So I'm going to come over here, hit New Item, and back up here I'm going to make sure that Visual C Items is selected, and then step definition is what I want. And this is just a plain old C# file. And in here I'll just call this scoring steps. Great. Now once that gets added in, it's added again from a project template. I have a bunch of code in here, and these are what steps look like. And basically they are methods with a specific name, and there's an attribute up here that kind of tells Specflow, hey, for that gherkin step, match it against this method. So that's how it finds it. So given how I've entered blah 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 into the calculator, well, that doesn't exist. And if you come back over here, I don't have that feature anymore. I took all that stuff out. That was boilerplate stuff. What I need to do is actually have steps for the stuff I wrote. So at this point, we're at a bit of a conceptual leap because we don't really have a way of doing that just yet. I'm not really too sure what attribute to use, nor where to put it, nor what to call my method. And so we'd be at a bit of a problem, but for us, luckily, we are using Specflow, which is also a code generator, as you can see. When it doesn't have the step to fire, it tells you you need to actually go and create this. And one of the cool things it does is it says, here is the code I'm expecting, so I can copy it out of here. Great. So what I do now is I just paste that right in there, and in it goes. That's cool. All right, so the next thing I'm going to do is I'm going to cut and paste each one of these guys, or copy and paste, I should say. And that needs to go there. And I'll do it with this last one here as well. And I think I have an extra brace in there. I do. Great. All right, so those are in there. Now I have the steps defined. So yippee skippy, I have features, I have scenarios, I have steps. Those steps are now defined in code. Now what? Well, now I've got to write some actual code. So how do I actually set this up? Given I am on the first frame. Aha. Well, now I need to actually implement the code that I'm supposed to be writing. This is a pretty good workflow for me because it's telling me specifically what I need to do. And I've defined these steps, execution steps with my manager, and everything is going great. All right, well, that means I need to actually create some application code. So what I'm going to do is come over here, create a class, and I'm going to call this Super Scorer. There we go. In it goes. And I'll make this public. So what I need to have in here is just the ability to know that I'm on a given frame number. So that's simple enough. I should probably just have a property here called frame. We'll leave it like that. And by default, I should probably put in a constructor here that says frame equals 1 on start. Awesome. All right, so that's good. So now what I can do is I can actually fulfill this step. I can take out this flag right here, which doesn't necessarily throw. It just says this is pending. I'm going to get to it. And all right, that's great. So now what I need to do is to use that code from my super score, and I can say var score equals, and we can probably even throw an assertion down there to make sure, and we just use control period to get the using statement, assert.r equal 1, and then score.frame. Okay, well, I have just fulfilled that step. Awesome. We are on a good thing here. When I bowl a strike. All right, so our super score is going to need to know when someone bowls something. So probably what we can do is add some code in here, such as a method, the easiest thing possible. We need to do some kind of scoring method here. And there's two parts when you're bowling. There's, of course, the first ball and the second ball. That's part of a frame. For those of you who don't bowl out there, I'm sorry if I'm leaving you a little bit behind in terms of bowling scoring. I figured that maybe this would be a game that a lot of people would understand. So what I'm going to do is I'm actually going to have two methods that operate differently because, as many of you might know, scoring actually happens differently between the different balls within a frame. So what I'll do is I'll just say score first ball here, and then I'm going to ask which frame it is. And then I'm going to ask how many pins were knocked down. Pins knocked down. There we go. Actually, I don't need to ask what frame it is. I should already know. Okay. Pins knocked down. Okay. Well, when I bowl a strike, that is, when is that? That is when we knock down all the pins on the first go. All right, so we don't really have any notion yet of what we need to do. So what I'm going to do is just come back over here to scoring steps when I bowl a strike. And I actually have to use the same score. So what I'm going to do is I'm just going to come up here and I am going to set a super score that my entire class can use. And we'll just call this scorer. And we can say, let's the assertion, leave that there. All right, and when I bowl a strike, and we can come in here and say score.score. First ball, pins knocked down 10. Okay, we're bowling strikes. That's great. Then I should see an X and a message that says, good job. Okay, well, we need some feedback now. So we need to be able to show the user their score and a message. Okay, so let's go back over here to the super score. And what I can do is, again, add a string here. We'll just call this bowler message. And then over here, we can say, let's make this a string, and then we'll say score. Now it needs to be a string, so I imagine we're going to show numbers and or just about anything on here. Great. So what I want to do in here is if this is a strike, I can say pins knocked down equal to 10. All right. So now I can come back over here to the steps, and I can do an assertion here, and I can say assert.r equal bowler message. And then I want to do another assertion in here, r equal, and then I want to say x and score.score. Okay. Well, now that that's done, let's build this. And when I build it, my test stuff is going to reload automatically, which I love. And boom, look at that! I get all greens, all green check marks. It's all passed. That's very exciting. I want to refactor this a little bit because I don't like having this mean a specific thing, such as is it a strike? So in case, or in this case, I want to make sure I come back over here and say is strike. I'm just simply going to return is first ball and pins knocked down equal to 10. That's it. All right, so now what we can do is come back in here. This is the refactor part of red-green refactor. And then I can just say if is strike. And then I'll say true. This is the first ball. And then pins knocked down. Great. Now we've loosened that up a lot. All right. So now that we've done that, oops, missing a paren. There we go. So now I'm going to come back in here, rebuild this, and rebuild this too. And then we're going to rerun our tests and make sure that everything worked as we wanted to. And yes, great. Okay, refactored. We're all good. Okay, well, we have our scoring feature kind of off the ground here. Typically what you would do is you would sit down and write out all of the specs. And I mentioned this previously, but really what you can think of this surface right here when you're talking about a feature, this is your notepad. This is the thing that you will jot down what it is you're trying to do. And you can reword this, you can rewrite this, spend a little time up front understanding it with the other people on the team so that you get it nailed down. Once you get it nailed down, then you can start writing code and you can execute against these specifications. It really is a quick, handy way of doing this. I'm going to write some more scenarios. This time I'm going to do a little bit on the negative side. What happens when you bowl a gutter ball? Okay, I've added in some more scenarios here. And if you're scanning this and taking a look at the syntax, something you might notice straight away is it's a little bit repetitive. I'm sort of using the same wording, and that's by design from the Cucumber guys and from the people who wrote this DSL Gherkin, is that you can actually reuse a lot of these steps. They're meant to be reusable. And I'll show you that in just a second. But one thing you want to keep in mind is that your step files can really grow. And if you have to start writing methods for each step, it kind of gets painful. So in this case, take a look at this right here. I should see an X and a message that says, good job. Well, down here, what if I bowl a gutter ball? Then I should see a 0 and a message that says, you'll do better next time. What if I, really goof up and bowl a gutter ball in every frame? Then I should see a 0 and a message that says, you need gutter bumpers. All right. Well, so that's an interesting thing. This is all worded the same. Wouldn't it be nice if I could, in my steps, allow for parameters to be passed in? And the good news is you can. So if we come back over here, what I could do is I could rewrite this here. So instead of hard coding these values, which I shouldn't, I could use regular expressions. So to do catch all for everything, I just put in a dot star, and then I come over here and I'm going to copy that, and then I'm going to paste that in. When you do that, when you put in regular expressions, what you can now do is to pass methods into this, arguments into this method right here. So the first position here is going to be a string, and it's going to be, let's just call it score, and the next one is going to be a message. This, Specflow is going to look at this attribute here and say, aha, I need to parse this out. This regular expression, I'll take those matches, drop them into, using reflection, into this method so that they can use it in the assertion. All right, so what I can do in here is instead of saying good job, an X, I can say score, and over here I can replace this with message. Great. All right, let's make sure nothing broke, and if I build this, I'll pull this over, and great, everything is passing well, except I don't have a method for this. I added this in for fun because I wanted to add in an audio music for when they score a strike. I don't know why I put Green Day. But what I want to do is I'm going to add this method in, and I'm going to do the same little trick that I just did. So I'll come over here to scoring steps. I'm going to drop this down. And instead of Green Day, I am going to copy this and pop this in, and I will say string song. Great. And then I'm just going to say assert r equal. Now I don't have anything for a song being played, so I'll come back over here to our super scorer, and I'll add in song to play. Great. And then if it's a strike, I will say song to play. Still don't know why I put in Green Day. All right. So come back over here to our steps, make sure this is in here right, and this is going to be the song, and we'll say song to play. There we go. Song. Great. All right. Now let's go rerun this. We'll build it. This is going to fire up NUnit, and we should have a green check mark, and we do. Okay, we are set and ready to go with the rest of these features. And so what I'm going to do is just run this, and we're going to see, yes, question marks everywhere. Lots of stuff is pending. But the cool thing is we're able to reuse a lot of our steps. So really the only methods I need to implement are 1, 2, 3, and 4. All right, so let's go jam in some code. Let's do that right now. I'm just going to kind of tail this at the very end down here, and let's add this in. All right, when I bowl a gutter ball, that's easy to do. So what I could do is score first ball. Instead of 10, I'm going to say 0. Okay, score first ball 0. Simple enough. And then I'm going to come back over here and copy in the next method. And let's see, given I have bowled a gutter ball already. Okay, well now this is a bit of a problem because I don't have any notion of second frame or frames bowled and so on. So what I need to do is I actually have to come over here, and I need to have another method in here called, let's call this score second ball and pins knocked down. All right. Okay, so what I need to do is now going to put in some logic here for tracking the score and for also advancing the frame. Okay, so right here we haven't had any notion of tracking a score yet. So what I should probably do is come in here and say, let's say pins total. So let's do that. And one thing to keep in mind as I write this is that I'm paying attention to Yagni. You might look at this and say, where's your interfaces and what are the things you're trying to do? I don't need them yet. I'm just trying to satisfy these specifications. This is helpful in many ways. It's going to kind of keep down the amount of code I write. It's not going to let me go off the deep end implementing a big system because requirements are going to change. And so if I keep this as simple as possible until I need to lock it down, then it's actually going to be a big benefit for everybody. Okay, so I will just add this pins total. We're going to say plus equals pins knocked down, and then we're going to give this line the same line as up here. Score second ball. The next thing we're going to do is we're going to advance the frame. There we go. And knowing that bowling only has 10 total frames, what I want to make sure here is if frame is less than 10. That's going to be my little test here because we don't, of course, don't want to advance the frame. Okay, there we are. Okay, so I did all that, but what is this thing asking me to do back here? Given I have bowled a gutter ball already. All right, dot score first ball as 0. Great. And great, so now I have a gutter ball already. We know that. That is the setup. We really don't have anything to assert because there it is. And now what do I have to do? Come back over here. We'll kind of keep jamming with our code. And let's add this in. When I bowl another gutter ball, when I bowl another gutter ball, we'll just do that again. And then I think we have one more to do here. Yes. Given I bowl a gutter ball on every single frame. That's great. A new one. What I'm going to do is I'm going to do a loop here. And let's just make this go I is 0, I is less than 10. Let's make this 1, keep it consistent. I is less than or equal to 10. And then I'm going to have the score score a first ball, and then 0. And then the scorer is going to score a second ball. And then again have this be 0. All right, that's it. That's all we need to do is to set that up. That score is going to be used by something next. And what is that something next? Well, come back to our feature. We'll come back here to the very bottom one. Given I pulled a gutter ball in every frame. So this assertion is going to be the same thing every single time, and that's awesome because I'm reusing these steps. Come back in here to these steps. I don't really have all that much code. Okay. Well, let's build this and see how it comes out. Now what we're going to see is a bunch of reds, and that's exactly what we want to see. So come back over here, and boom, great. It's not uncertain anymore. It's all failing. That's exactly what we want. So let's take a look at this very first one and get the logic in here. Expected you'll do better next time. So what is the condition? What is the behavior that we're coding against? If we take a look at this and read it, okay, given I'm on the first frame, when I bowl a gutter ball, we need to have this message right here in the score. Easy to do. We'll come back over here to our code, crack open super score, and so we're on the first ball. And so let's see if it's a strike. Great. What if it's a gutter ball? So let's create a method is gutter ball. Why not? Bool is gutter ball down equals 0. All right. And so in here I can say if is. Let's do an else in here. It should never fire, but why not? It's all the same, testing the same stuff. If is gutter ball, pins knocked down, and we know this already that this is the first frame, so all we need to do is we need to reset these guys right here. We don't have a song to play, that's good, and give them a little inspiration. You'll do better next time, and the score is going to be a 0. Okay, so let's see if we've fixed that. We'll hit build, pull this thing over. It's running our tests, which is what we like. Boom! That's exciting. That wasn't all that bad, was it? Okay, so let's see. We got it in bowling a strike. Let's do bowl 2 gutter balls in a frame. All right, yeah, you need lessons. Okay, so what's the condition here that we're coding against? Given I've bowled a gutter ball already, so we're on the second score here. When I bowl another gutter ball, okay, you need lessons, right? Because 2 in a row is really bad. Anybody out there has done that before? Well, I guess you need lessons. Okay, so that was on score first ball. On score second ball, we got to check something else. All right, so what we need to do is say if is gutter ball, pins knocked down. Okay, and let's see, how are we going to know? Let's see, if it's a gutter ball, how are we going to know the first frame score, or excuse me, the first ball score? We don't. So what we need to do is to add that ability in, and we'll say first ball score. You probably need this, of course, for scoring up spares and strikes later on. I'm not going to do all that stuff. So we'll say first ball score. Then down here, we are going to just say first ball score is going to equal pins knocked down. Awesome. Then we can come back up here if it's a gutter ball, and then we can add a condition here and say and first ball score is 0. Great. And what we can do is we can add that message bowler message equals you need lessons. Great. And score is going to be 0. Okay. I think we're good. So let's see if we satisfied that. We'll hit build. We'll pull this thing over. And we've got, nope. You see, oh, that's right. You need lessons. I blew that. Okay. That's it. Oh, we don't have that, do we? All right. So we've got a little bit of a bug. All right, well, let's chase this a bit. This is running okay. So it looks like this isn't being called. Score second ball. All right, so what we need to do is retrace our steps a little bit. When I bowl another gutter ball. So it looks like I might have goofed up. When I bowl another, yes, another gutter ball, this should be score second ball. Okay, that was easy to find and fix. All right, so let's come up here, build. And this is going to rerun our test for us. And boom, we got a green. It's exciting. Okay. Okay, finishing the game with nothing but gutter balls. All right. So you need lessons was what was put in there. Right. You need the gutter bumpers is what we want to see. Okay. So let's go back over here to our super score. What I can do in here is I need to actually check for a condition to see if this is the last frame. So what I can do is just say if frame equals 10, pins total equals 0. That is a nothing but gutter game. We're going to build this, see if we did it, and we didn't. Oh, we forgot to say a trombone. Oh, yes, of course. So we need to put in the song to play is going to equal sad trombone. All right, so now that we've done that, and we build it, come back over here to NUnit. What you got for us? Green. All right, that's exciting. So now what we can do is run this all together. Make sure everything is green. That's great. All right. Well, the cool thing is you look over this, you see we did a lot of work. We actually did it in a fairly short time. We literally did it with the specs guiding our way, which I think is pretty neat. And if you ever get lost with a given condition, all you got to do is kind of read back over each scenario here, and you're good to go. All right. Something else to point out when you're doing BDD is that look at our tests. These are, again, focused on the behavior of the application, not so much the functionality. So if at any point in time we decide that we need to refactor, we don't have a ton of tests to carry around with us. And I think that's pretty neat. All right, so there's one last thing I want to do here, and that is to pretty up a report for the team. And I can actually take it with me. The progress meeting is coming up. So what I want to do right now is I'm going to go up to Tools, and I want to say Save Results as XML. So I'll just save the test result.xml inside my project directory, and if I come back over here, make sure that it's there. I'm going to drop this thing open, and I'll take a look here. Test result.xml. That's great. Okay, what I'm going to do is I'm going to use an executable that comes along with Specflow, and it is in your installation directory, which is in Program Files, x86 if you're on a 64-bit machine. And I'm going to do my favorite thing, which is work with external tools. There's two things you can do to generate an output report. You can have Specflow parse out your NUnit execution report, which is the XML file I just generated, or you can have it do a step definition report. I am not successful in getting this thing to run. I'll just tell you that right now. All right. So the command is going to go out to specflow.exe. Then you want to make sure you pass in an unit execution report. The next thing you want to do is tell it the project file name, which in this case is going to be specs.csproj. And finally, the initial directory, of course, that it's going to look for that is our project directory. That's where this whole thing is going to run. All right, so I hit cancel. What I want to do right now is execute that. I'll go to Specflow, and it is going to grab that XML file for me. It's going to jam some stuff out. Now if I come over here and I refresh, boom, I got a nice new file in there. Awesome. So now what I can do is open this thing up in Windows Explorer by going all the way down to the bottom, open file in Windows Explorer, or open directory. I have an HTML file in here. Look at that. Print that thing out. That's pretty cool stuff. You can show the team this and see how things are going. It's pretty neat to show them a nicely formatted report like this if you don't want to just show the NUnit output. It's up to you. Okay, well that's BDD with Specflow. Hopefully you've gotten a flavor of how the workflow goes down. If you have any questions, feel free to email me or the Specflow team. Thank you so much for watching.